Determine using Venn diagrams whether the expressions A union B intersect C complement and A complement intersect B complement union C are equal. Now, this is kind of a different twist, but you know, our methodology is going to be very much the same as what we used in the previous 2 or 3 examples. We'll set up our Venn diagram, and this will be set A, set B, set C, and now we'll label the disjoint regions that comprise the entire universe. This is set 1, 2, 3. Then, going across the middle from left to right, 4, 5, 6. This is region 7. And that region that doesn't happen to be in any of the sets A, B, or C, that's region 8. I think the first thing that I'll do is find out exactly what regions are comprised in this expression. And then I'll find out what regions are comprised in this expression. And I'll see if they turn out to be the same. Now, looking at this expression, this seems to be the nasty part right here, so I'm going to do that first. I'm going to get the complement of B intersect C. And to do that, I'll write down the elements in B. I'll write down the regions that are comprised by B. 2, 3, 5, and 6. Those are the regions that comprise B. Now I'll do the same thing for C. C is comprised of regions 4, 5, 6, 7. So I'll say 4, 5, 6, 7. That's C. Now I'm going to do the complement. Whoops, no, I can't do that yet, can I? I'm going to have to do B intersect C next. And what is B intersect C? It's the set of all elements that are both in set B and in set C. And if we do this in terms of regions, B intersect C is the set of regions that are contained both in set B and in set C. What do we have here? Let's see. Region 5, region 5, that's in both, and region 6. So regions 5 and 6 are in the intersection of B and C. Now, I'll give my attention to the complement of B intersect C. And remember what the complement of B intersect C is. It's the set of all elements in the universe, or all regions of the universe, that are not in B intersect C. So what I'll do, I'll just write down all the regions of the universe I'll write down all of the regions of the universe, and to get the complement of B intersects C, I'm going to take all of the regions of the universe and remove those regions that are in B intersects C. What this leaves me with are all of the regions of the universe that are not in B intersects C. Okay, that's good. That's good. Now that I've done the nasty part, figured out what this is, I'm going to do the union of A and B intersects C complement. So first, I'll write down the regions of A. And A comprises regions 1, 2, 4, 5. Now I can do A union B intersects C complement. And what is this going to be? It's the set of all elements that are in A, or all the regions that are in set A, and the set of all elements, or the set of all regions that are in B intersects C complement, or both. So anything that's in set A is going to be in here. Anything that's in B intersects C complement is going to be in here. Anything that's in either of these two sets is going to be in there. Set 1, set 2, or region 2 rather. Region 3 is in B intersects C complement. Region 4 is in both. Region 5 let's see. Region 7 and region 8. 1, 2, 3, 4, 5, 7, 8. Looks like the only region that's not in this union is region 6. Son of a gun. Okay, we're back. Just for future reference, we've written up top what A union B intersects C complement equals. So we've computed what that is. We're going to turn our attention to this set now and see what regions comprise this set. And in typical Pat Rossi fashion, I'm going to tackle the ugly part first. I want to compute B complement union C. And in order to do that, I think the first thing I need to do is to get B complement. Well, let's see. I guess there are a couple of ways I can do this. Might as well be consistent and do it the way that I think I've been doing it so far. I'll write down all of the regions in the universe. Okay, there are my 8 regions. B complement is the set of all regions in the universe that are not in set B. Region 2 is in set B, so it's not in B complement. Region 3 is in set B, so it's not in B complement. Region 5. Region 5 is in set B, so it's not in B complement. In region 6. Region 6 is in set B, it's not in B complement. So B complement consists of the sets 1, 4, 7, and 8. We've got B complement, and we want to compute the union of B complement with set C. So let's write down the elements in set C. Set C comprises the regions 4, 5, 6, and 7. Okay, I'll write it this way. 4, 5, 6, whoops, 6, and 7. The union of these two sets consists of all of the elements or all of the regions that are in B complement, plus all of the regions that are in C, or both. And we have region 1, we got region 4, we got region 5, we got region 6, 7 is in both, so we can definitely put that down. And we got region 8. B complement union C comprises regions 1, 4, 5, 6, 7, and 8. So we did the nasty part. Now we're going to have the intersection of A complement with this thing. So let's do A complement. And we'll do it the way we've always been doing it. We'll write down all of the regions in the universe. We'll write down all of the regions in the universe. And then we'll remove all of these regions that aren't in set A. The complement of A is the set of all regions of the universe that aren't in set A. So we'll remove those regions that are in set A. We'll remove regions 1 and 2. And we'll remove region 4 and region 5. A complement is region 3, region 6, region 7, region 8. Okay, now we are ready. We're ready to compute this whole colossal mess here. A complement intersect B complement union C. And this is going to be the elements that are the regions that are contained both in A complement and in B complement union C. This is an intersection. So anything in the intersection has to be in both A complement and in B complement intersect C. Which regions do they have in common? Let's see. 1 is not in A complement. 3 is not in B complement union C. 4 is not in A complement. 5 is not in A complement. But oh, look at these guys right here. Regions 6, 7, and 8 are in both. So A complement intersect B complement union C consists of regions 6, 7, and 8. Okay. Beautiful. We'll tabulate the votes and get right back to you. We rewrote our previous result. A complement intersect B complement union C comprises regions 6, 7, and 8. Well, let's see. These aren't the same set of regions, aren't they? Or are they? These two sets are not comprised of the same regions. So guess what? They ain't equal. And we'll put a big fat not equal sign there. And is that what I meant to write? Yes. A union, the complement of B intersect C, is not equal to A complement intersect B complement union C. So that is our result. Wonderful. Now, did it take a while to do? Sure it did. But this is a sure 10 points that we have in the bank towards a 100. And we want to set high standards for ourselves. We're not going to be satisfied with a C. We're not even going to be satisfied with an A. We want to get 100. So let's keep that frame of mind throughout our academic career. We want to set high standards for ourselves. And we're not just aiming for an A, we're aiming for 100.